Assalamualaikum. Today our group will present to you guys about our group assignment. So basically we are from group 1 and our group assignment is about convolution. So what is convolution? Convolution is a mathematical tool for combining two signals to form a third signal. Therefore, in a signal and a system, the convolution is very important because it relates the input signal and the impulse response of the signal of the system to produce the output signal from the system. In other words, the convolution is used to express the input and output relationship of an LTI system. So basically you can see the picture. The first one we have input signal in terms of xt, and we go for LTI system in terms of ht, and then the last one is output signal in terms of yt. For your information, in the convolution, we have three properties, which is the first one is commutativity, and then the second one is associativity, and then the last one is distributivity. For commutativity is a property of convolution being commutative with which both LTI system yield the same output, which is xt multiplied with ht is equal to ht multiplied with xt. For the second one is associativity, is a property of convolution describe how three or more signal convolve. And the last one is distributivity. This property of convolution describe how parallel systems are analyzed. By example, xt multiplied with h1t plus xt multiplied with h2t is equal to xt multiplied with total up h1t plus h2t. For graphical approach, we have two graphs, which is ft and ht. For ft, it is using sine, so this is the graph for the input signal, and the next one is graph for ht in terms of unit step function.
For the next part, we have the solution using graphical approach, that is convolution yt equal ft convolve with ht. As we can see, our group choose the ft signal as the fixed signal while the ht signal is the moving signal. So for the figure 1, for t less than 0, we are integrating 0 equal to 0 because there is no overlapping between both signals. For the next signal, we have overlapping between both signals. From 0 to t, integrating 2.5 sine pi tau times with 2. And we have the answer 5 over pi times with 1 minus cos pi t. Moving on with the next figure, as we can see, almost fully overlapping ft signal inside the ht minus tau signal, like the last figure, and still integrating the same equation, that is 2.5 sine pi tau times with 2, but with different limit, that is 0 to 1. And we have the answer 10 over pi. Next, we're starting to look the first rectangular in ht minus tau signal, starting to leave the ft signal, and we have slightly overlapping between both signals, and we integrating from t minus 1.5 to 1, 2.5 sine pi tau times with 2, and we have the answer stated below, 5 times with negative cos pi in bracket t minus 1.5 over pi plus 1 over pi. For this figure, we can see the first rectangle from ht minus tau signal is fully leaving the ft signal. We can see the square signal under the graph is moving toward the ft signal, and we have a little overlapping under the ft signal. So we have the integration negative 2.5 times with integration from 0 to t minus 2 sine pi tau plus 5 times with integration t minus 1.5 to 1 sine pi tau, and we have the answer stated below represent the overlapping value under the graph. So next we have the ht minus tau is moving slightly like the last figure. So we have from t minus 2.5 to t minus 2 negative 2.5 sine pi tau, and we have the answer stated below.
So we can see the ht minus tau is almost leaving the signals ft fully. However, we still have the integration from t minus 2.5 to 1, negative 2.5 sine pi tau. and the integration. So for the other figure, we can see that ht minus tau is fully leaving the ft signal, and there is no overlapping signals. And for the integration, it's like the first integration we did. So we integrate 0 and we will get 0 because there is no overlapping. So for the last one, this is the final loop of the signal after all the combination of integration that we did. So we have under the graph is the combination of the function that will be to get the graph that will be generated by MATLAB. Thank you.
Hello, my name is Abdullah. I will briefly explain about the code. Firstly, here we have the f of t and h of t. We define it by using inline function. Inline function allows you to defining functions. And here we have the incremented value of tau and the tau value from -1 to 4. And here also we have y of t. You can see with y of t we have nan. Nan refers to not a number. Usually resolves operations from 0 over 0 or infinity minus infinity refuses to be plotted in MATLAB. So basically to prelocating the y of t value with nans to ensure that only the computed value for y of t will be plotted. And here we have the looping, time indexing and so on, and here the most important thing is the convolution operation. As you can see here we have the h of t minus tau as a modified function, and f of tau is a fixed function, and here the multiply. This dot is to change the operation from matrix operation based on linear algebra to element by element operation in MATLAB. And here the approximation of integral, and here the subplot. Subplot allow you to have more than one graph in one figure. As you can see here we have this and this, two subplots here to have two graphs in one figure. And here plot is to plot the modified and fixed function, and here to change color and line and so on. And here the title x label axis. Here refers to x-axis and here refers to y-axis. We choose negative 2.5 to 2.5 to make the whole graph appear here. And to create the shaded area we use this line of code. What I mean by gray shaded area is this one. As you can see here is the overlapping. See, this is the gray shaded area. What I mean, the overlapping. And to record plot objects so the gray area does not occupy with each other, we use get and set syntax. And here also plot again to plot the output function, title again, x label, axis. This is also refers to x. This is also refers to y. And draw down is to update the graphic window. Okay, so this is basically the code. I will run it last time. Okay, that's it. Thank you very much.
In conclusion, convolution is a mathematical tool to combine two signals to form a third signal which relates the input signal and the impulse response of the system to produce the output signal from the system. The term convolution refers to both the result function and to the process of computing it. As we can see in the slide, by using the convolution, we have obtained our output signal yt from our input signal ft and the impulse response ht. Hence, the convolution theorem can be used beneficially in many applications that include probability, statistics, acoustic, spectroscopy, signal processing and image processing, geophysics, engineering, physics, computer vision, and differential equations. Generalization of convolution also have applications in the field of numerical analysis and numerical linear algebra, and in the design and implementation of finite impulse response filters in signal processing. So I guess that is all from us. Thank you.